registers. So to indicate the status of the processor, that means to indicate the status of your operation. So when you perform some operation, what kind of any kind of operation in processor, so what is the outcome of that operation? Depending on the outcome of the operation, the flag, the value of the flags in the processor will be changed. Okay, those are those the value of those flags indicates the status of the operation, what kind of operation you are going to perform, and that's why these are called status flag. Status flag also, so status flag is one kind of flag
The
registers.
flags,
So why it is called
the
status
value
flag?
of the
Because it
flags.
indicates the status of the operation. It indicates the status of the operation, what kind of operation the user is going to perform by the processor. That's why it is called status flag. Okay, so you can see here in figure 5.1 shows the flag registers. So if you look at figure 5.1, you can see the flag register. This is the flag register. You can see here this figure. So this is the figure of the flag register. So this is a 16-bit register. Each and every bit indicates flag. So this is a 16-bit register, okay? So and this 16-bit register is called flag registers. And it has 16 bit, as you can see. So bits started from 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So in total there are 16 bits, and each and every bit indicates the status of the operation. That's why these are called flag registers. So so figure 5.1 shows the flag registers, and there are two types of flag registers. The first one is called status flag. Status flag. So what status flag does? Status flag reflects the status of the operation. If you want, you can write that. Status flag reflects the status of the operation. What kind of operation user is going to perform. So how many status flags are there? Let's see. So status flags are located in bit number 0, bit number 0, bit number 2, bit number 4, 6, 7, and bit number 11. So status flag in bit number 0. So this is a status flag, bit number 0. Then bit number 2, we have a status flag here. Then bit number 4, we have another status flag. Bit number 6, we have another status flag. Bit number 7, we have another status flag, and bit number 11, we have another, that is the last status flag. So how many in total? One, two, three, four, five, six.
Six.
Yes, so there are 6 status flag in 8086 processor, and rest we have some control flag here. Control flag, what control flag performs? Control flag enable. Okay, status flag reflect the status of an operation. Okay, so status flag reflect the status of an operation. And what control flag does? Control flag enable or disable certain operation by the processor. So control flag enable or disable operation. Status flag reflect the status of an operation. That is the difference between status flag and control flag. Okay, so you can see here control flags are located in bit number 8, bit number 8, bit number 9, and bit number 10. So in total, so there are how many flags registers are there? There are 9 flag registers. 6 of them are status flag, and 3 of them are control flag. And control flag located in bit number 10, bit number 9, and bit number 8. So these 3 are control flag. So you can see here DF, IF, and TF. These 3 are control flag, and 6 status flag are CF, PF, AF, ZF, SF, and WF. These six are status flag. So what is the so flag registers? How many flag registers are there? There are 9 flag registers, and among those 9 flag registers, how many status flag are there? 6 are status flag, and how many control flags? 3 are control
Three.
flags. 3. So Hafiza, can you say what is the difference between the status flag and control flag?
Yes, sir. Their status flux are 6 and control 3, sir.
Yeah, but what is the difference between them? I mean, in terms of operation, what status flag does and what control flag does?
Actually, sir, I join in 20, sir. 20, then 15 minutes left, sir. 5 minutes left, sir.
Okay, got it. Okay, who can say what is the difference between status flag and control flag?
Status flag reflect
Mhm.
the status of operation, and
Yes.
control flag it enable or disable the operation.
Right, very good. So, status flag reflect the status of an operation, whatever operation you are going to perform, and whether you can perform the operation or not, that is determined by the control flag. So, control flag enable or disable operation, status flag reflect the status of an operation. Okay, so let's talk about status flag. You already know that there are 6 status flag, so we are going to discuss each and every status flag in details. So it is what it is. It says, as stated earlier, the status flag uses the status. The processor uses the status flag to reflect the result of an operation. Look, so what it says, the processor uses the status flag to reflect the result of an operation. That means if you want to get what kind of operation are performed, you can look at the status flag and you can assume that this kind of operation is already performed. So if sub x comma x is executed, so when you execute sub x comma x, what value will be stored in the destination? Can you say? If you execute sub x comma x, what value will be stored in the destination? 0, exactly. So because you are uh, subtracting the content of x from the x, okay, so 0 will be stored definitely. So that's why when result is 0, the 0 flag becomes 1. So the 0 flag becomes 1. So when you execute some kind of operation like sub x comma x, then 0 flag will become 1, and thereby indicating that a 0 result was produced. Okay, so that means this is just an example. So if your result is 0, at the time the 0 flag will immediately become 1. Okay, so you can say 0 flag will become 1. That means the flag registers has 16 bit, and 0 flag is located at bit number 6. So bit number 6 will become 1 when your result is 0. Okay, so now let's talk about carry flag. So we'll start from bit number 0. So we'll start from bit number 0 and we'll go one by one. And the second, this bit has no meaning actually. It will always remain 0. It will always remain 0. And this bit, other bit, so it will always remain 0. It has no meaning. So all those bit always remain 0. All those bit. Okay, so we'll start with the first one, CF, then we'll go to the PF, then we'll go to the AF, then we'll go to ZF, then SF, and then these are the control flag, then we'll go to OF. So carry flag, first one, the carry flag, CF equal 1 if there is a carry out from the most significant bit MSB on addition. So, or okay, so CF equal 1 if there is a carry out from most significant bit MSB on addition. So if you perform an addition operation and if you get a carry, then CF will become 1. So it simply means that suppose if you perform an 8-bit operation, and in 8-bit operation you know that highest number is 255, that is the highest number. you'll get a carry if your number is greater than the highest number, right? So if you add 1, then you get 256. So if you get 256, you'll get a carry. So in addition, if you get carry, so in that case, the carry flag will become 1. Is that clear?
Yes, sir.
Okay. Or there is another condition, or there is a borrow into the MSB on subtraction, or there is a borrow into the MSB on subtraction. And if you subtract, and what is MSB? You know that, right? What is MSB? Can you remember that?
Yes, sir. Most significant bit.
Exactly. So most significant bit, suppose we have a lots of bit here, and this is the most significant bit. So how can you get borrow in the most significant bit? So that means the number you are going to subtract, that will be higher, right? So here suppose you have 1, and all those bit, ignore all those bit. Just consider the most significant bit when you perform all those operations, and when you come to the most significant bit, and this is the 0 and this is the 1, you can see here. So that's why you have to borrow here, right? At the most significant bit, MSB, you have to borrow. So
Yes,
that
sir.
means when you subtract a bigger number from a smaller number, in that case you will get borrow, right? So when you subtract a bigger number from a smaller number, then you will get a borrow, and in that case the CF, the value of CF will become 1. So there are two conditions when value of CF or carry flag become 1. First condition, when you add, if you get a carry from the most significant bit MSB on addition. So for addition, you'll get a carry from MSB, and in subtraction, you'll get a borrow from MSB. In these two conditions, the carry flag will become 1, and for the other condition, it will remain 0. For other condition, it will remain 0. And carry flag also affected by shift and rotate instruction, that is in chapter 7. So we'll discuss later if we go there. Okay, so that is how the carry flag works. So then come to the parity flag. Parity flag. Parity flag means PF. So in short, it is PF. So parity flag located in bit number 2. You can see here. So carry flag located in bit number 0, and parity flag located in bit number 2. Parity flag. So when PF equal 1, so PF equal 1 if low byte of a result has even number of 1 bits, even parity. Suppose you did some operation, maybe you did some addition, maybe you did some subtraction, or what kind, or multiplication, division, does not matter. The thing is, if you get a result, and result has, if it is 16 bit, how many bytes we have in 16 bit? Can you say? How many bytes we have in 16 bit?
Sir, 8 bit
2
equal to
bytes.
1 byte.
2 bytes, sir.
2 bytes, right? So in 16 bit we have 2 bytes. So when parity flag will become 1. So parity flag equal 1 if the low byte of a result has even number of 1 bits. So low byte has even number of 1 bits. That means low byte has how many 1? Low byte has how many 1? Can you say low byte has how many 1? Low byte has how many 1?
Low byte.
Yeah,
Even
low
number.
byte.
No,
in
one.
total. In total, low byte has how many 1?
0 1.
No, I'm saying yes. What did you say?
একটা হওয়ার কথা না, সবগুলো তো 0.
না, আমি বলতেছি যে লো বাইটে ইন টোটাল কতগুলো 1 থাকে যদি সবগুলো 1 হয়?
স্যার তাহলে তো 8টা 1.
8টা 1, স্যার।
8টা 1 থাকে, এটা কেন বলতে পারছেন না? একটা বাইটে কয়টা 1 থাকবে? ম্যাক্সিমাম 8টা।
Yes, sir. 8টা byte. 1.
8টা বাইট
আসছি
বলছেন।
স্যার।
8টা 1 থাকবে।
8টা 1, ওকে। সো তাহলে আমাদের হচ্ছে লো বাইট। সো লো বাইট ম্যাক্সিমাম we can have 8 1 in low byte, right?
Yes,
So
sir.
low byte max we have 8 1. So now when PF will equal 1, suppose you get a result and you only consider the low byte, and high byte don't consider how many 1 or 0 in high byte. We don't consider high byte. So PF equal 1 if the low byte, it is said here, look, low byte of a result has even number of 1 bits. That means if low byte has 8 1, all 8 1, that means all 8 1, then PF equal parity flag equal 1. Is that clear? So all 1 equal PF equal 1. Then what about 6 1 and 2 0? 6 1 and 2 0?
স্যার এটা 1 হবে ইভেন নাম্বার হলেই তো 1 হবে
Yes, yes. So if there are 6 1 and 2 0, then also PF equal 1. What about if there are 4 1?
4 and 2 same sir, same result 1.
Yeah, 4 1 and 4 0, that will also PF equal 1. If there are 2 1,
1 answer will be 1.
still PF, the value of PF will be 1. And if there is suppose no 1, কোনো 1 নেই, তাহলে PF কত হবে? What will be the value of PF if there is no 1?
0.
0 sir.
No, if there is no 1, still PF equal 1 because there is no 1 means there are 0 1. Is that clear? So PF equal 1 if the low byte of a result has even number of 1 bits, even parity. That is called even parity. So which one are even parity here? 8 1, 6 1, 4 1, 2 1, and 0 1. 0 1 is, that means there is no 1. All are 0. Low byte 8 0. There are 8 0. There is no 1. But PF will be 1 because suppose your result is something like that. 1 1. Okay, so I have to write by this one, then it will be easier to write. So suppose low byte has 1 1 1 1. This is the high byte, then low byte. So for this result, if you get this result, what will be PF? PF equal how much? Can you say? For this result?
0 হবে
No, it will be 1 because it is the even parity. You can say low byte has no 1.
স্যার 0 একটা কম আছে স্যার
Oh, right.
এই জন্য 1 বলছি
Okay. Understand. Okay, understand. Now it is okay. Okay, so PF equal 1 now. Because you can say so low byte has 0 1. Yes. Okay, so then it said that it is 0 if low byte has odd parity. Odd parity means if there are 1 1 1, 3 1, 5 1, 1 3 5, 7 1, 7 1, then PF equal 0. That is the odd parity. For example, they have given an example here. If the result of a word addition is FFFE, then low byte contains 7 1 bits, so PF equals 0. You understand that? FFFE? Understand, right? For example, if result of a word addition is FFFE, the low byte contains 7 1 bits, so PF equals 0. You understand this line?
No
Or
sir.
not?
শুধুমাত্র একটা ই আছে বলে 0 হবে
Okay, so what you have to do, so this is the hex number they have given. So if you convert to the binary, you have to convert, the reference is binary, okay?
স্যার ই এন্ড এফ রে করলেই তো হবে এফ এন্ড ই লো বাইট
Right. So you can see how many 1 we have.
7 1 and 1 0
Okay, look, 7 1. That's why PF equals 0. Clear? Okay. Okay, good. So okay, so we understand CF, we understand PF. We are going bit by bit. So first we understand bit number 0, that is carry flag. Then we understand bit number 2, that is parity flag. Then bit number 4, that auxiliary flag, bit number 4. Okay, here is also we have an overview of that also given here. Status flag. There are 6 status flag. 1, 2, 3, 4, 5, 6. Carry flag, parity flag, auxiliary carry flag determined by AF, zero flag determined by GRF, sign flag. So in short, we can write SF, and overflow flag OF. And these are the control flags. So the control flags, bit number also given here. You can see bit number. Trap flag, interrupt flag, and direction flag. So this is their control flag. So we only started the first two, carry flag and parity flag. Let's talk about auxiliary carry flag. F. Okay, so auxiliary carry flag. So AF equal 1 if there is a carry out from bit 3 on addition or a borrow into bit 3 on subtraction. So AF equal 1 if there is a carry out from bit 3 on addition or there is a borrow into bit 3 on subtraction. So it simply means that suppose you have this one 1 1 1 1 0 0 0 1 1 0 0 0 0 0 0 0. So can you say what will be the AF if you add these two numbers? What will be the value of AF?
So 0 0 0, then again 0.
Yeah, so what is the value of AF? Can you say that?
Sir 1 এর পর মেবি 8টা 0 হবে।
বুঝি নাই কি?
স্যার 1 এর পর 8টা 0 হবে মনে হয়।
এফ 0 স্যার।
1 এর পরে 8টা 0 হবে মানে কি? আমি বলছি যে এইটা যদি আমরা এই অপারেশনটা পারফর্ম করি, so in that case what will be the value of status flag F?
Oh, okay.
Okay, so can you say what will be the auxiliary flag F?
Sir, 0.
So first read the definition properly. So AF equal 1 if there is a carry out from bit 3 on addition or borrow into bit 3 on subtraction. That is the definition. AF equal 1 if there is a carry out from bit 3 on addition or there is a borrow in bit 3 on subtraction. Okay, so you got it? What will be the value of F? Anyone?
Sir F equal to 1.
Yes, so AF equal 1. So how do you understand that? AF equal 1, can you explain?
Sir, we can add 1 1 1 and 0 0 0, then carry out 1, sir. The last 4 bit, 3 bit.
Yes, so you can say from bit number 3. So you have to calculate bit number 3 here first. So this is, bit number 0, bit number 1, bit number 2, and this is bit number 3. Now you have to look at, so you're going to addition. So is there any carry out from bit number 3? So that means bit number 3 we have 1 and we have another 1. So that means 1 1 equal, you know, that 1 0 10. So that means you got a 1 carry out, right?
Yes.
From bit number 3. So that carry out is added in the next bit number 5, bit number 4, sorry. So from bit number 3 we have a carry out in addition. That's why f equal 1. So if you perform this operation, then you will get f equal 1. Or you can also set that in emulator if you want. Okay, so then for subtraction, it is said that f equal 1 if there is a borrow from bit number 3. So how can we do that? So suppose uh, if you have the same thing, subtraction. So this is my subtraction. This is 0 and this is 1. Yeah, so okay, so should give it 1 here. So this is 1 and this is 0 0 0 and maybe 0 1 1 1 1. Okay, so we're subtracting that number from the second number. So what will we have for this case? Can you say that?
1, sir.
Yeah,
1,
still
sir.
1, because you have to look at the bit number 0, bit number 1, bit number 2, bit number 3. So in bit number 3, this is a subtraction, this is the bigger number, you have to borrow here, right? So you have
1,
to
yes.
borrow here. That's why f will become 1. So this is the understanding of flag, status flag f. Okay, so after that we have the 0 flag. You can see here 0 flag ZF. So ZF. So it said that it's very simple. ZF, the ZF is very simple. ZF equal 1 for a 0 result and ZF equal 0 for a non-zero result. So ZF equal 1 for a 0 result and ZF equal 0 for a non-zero result. So if I give you FP23 hex minus FP22 hex. So what will be the value of ZF? Can you say what will be the value of ZF for this case?
0.
0, sir.
Sure.
0, sir. That is.
Why?
Sir,
Sir,
result.
there will be value, sir.
Yes. So in this case, the value of you can say the value of ZF equals 0 because it has the value so of 0 0 0 1, right? That is the value. So it is a
Yes.
non-zero result. So for non-zero results, ZF equals 0. Very simple. And after that, we have sign flag. What it says, sign flag, SF equal 1. Okay, sign flag SF equal 1 if the MSB of a result is 1, right? So SF equal 1 if the MSB of a result is 1, this means the result is negative. If you are giving the sign interpretation, SF equal 0 if the MSB is 0. If the MSB is 0. So what can you say from this? So SF equal 1 if the MSB of a result is 1. SF equal 0 if the MSB is 0. So if I give you a number, you say whether the sign flag will be 0 or 1. Okay. Sign flag. So sign flag, it will be a sign flag. Suppose if I give you, what can I give you? So FFFB, that is my result, suppose. FFFP. FFFP hex. So that is my result. So what will be the sign flag? Can you guess?
1, sir.
Yeah, so sign flag equal 1. So you have to look at the MSB of the results. So if the MSB of the result is 1, then the sign flag equal 1. Simple. And if the MSB is 0, then sign flag will be 0. So suppose if I give you this number 7 FFFP FFF2X. So what will be the sign flag for this case? Can you say what will be the sign flag for 7 FFF2X?
Sir, 0 হবে sir.
Yes, so for 7 FFFX, it will be 0 because you know that the MSD of the result is 0. So that's why it is 0. And the last one is the overflow flag. So overflow flag OF equal 1 if sign overflow occur, overflow flag OF equal 1 if sign overflow occur, otherwise 0. Okay, so this is kind of tricky. Overflow flag OF equal 1 if sign overflow occurs. So how do you know that whether there is sign overflow occurs or not? How do you understand that? Whether we have sign overflow or not? How can you understand that?
Sir, there are some ranges of bit and what. Sir.
Yeah, can you say what is the sign range for 8-bit number? What is the sign range for 8-bit number? Sign
Sir, minus
range.
minus
128
128 to
to
Minus
127.
Minus 128 to
128 to
127.
127.
Okay. Now overflow indicates that overflow flag OF indicates that suppose you are working with 8-bit number. So you are working with 8-bit number. In that case, if your result is out of the range of 8-bit, then overflow will occur. Suppose your result is 128. So is there any overflow will occur for that case if
Yes,
the number
yes, sir.
Yes, sir.
yes,
No,
definitely.
sir.
So if you work with register L, BL, or L or ACE, BL or BACE, CL or CACE, DL or DACE, in that case overflow occurs. But if you work with register X, in that case overflow will not occur because 128 is within the sign range of 16-bit. But if you work with 8-bit, then 128 is not within the range of 8-bit, then overflow will occur. Similarly, if you get the result minus 129, still overflow will occur because minus 129 is out of the range of minus 128 to 127. So, and what is the range of sign number for 16-bit? Can you remember that? Range of sign number for, yeah,
Sir, 0
yes.
to 65535.
No, that is the unsigned range. We're talking about the sign range. Overflow occur, you say.
Sir,
If sign
minus
overflow,
32,000 কত
3 to
জানেন?
7682.
Sir, it is
Positive.
given, sir. Minus 3 to 768.
8 to
Positive
3 to 7.
3 to 767.
3 to 767. So, okay, so if you get reserves, I mean, out of this range, suppose in 8086, you only work with 16-bit data. So if your result is minus 3 to 7, 6, 9, then overflow flag will become what? Can you say? It will become 1. 1 because for 16-bit sign number, for sign interpretation, you are getting out of the range. Okay, so that is the discussion, but it is not that much simple. So let's discuss that. So how, okay, let's look at books. So how they discuss this overflow concept here. Okay, so if we go down, so then overflow, they only said that OF equal 1 if sign overflow occur, otherwise 0. That is what they only say. But they later they tell that the meaning of overflow is discussed next. So let's see how they discuss the overflow concept. So 5.2 article, the concept of overflow. So it said that phenomenon of overflow is associated with the fact that the range of number can be represented in a computer is limited. So in a computer, it has some limitation, unlike human brain. So in human brain, we have no limitation. So your brain has more memory than all the computer combined in this universe, but computer is not like your brain, so it has lots of limitation. So range of numbers that can be represented in a computer is limited. So that is the thing. That's why overflow occurs, otherwise there will be no overflow. So range of number in a computer, represented in a computer, is always limited. So then it said that chapter 2 explains, we already studied the chapter 4 decimal range of sign number that can be represented in a 16-bit minus 327682232. That is what we just discussed. So we already studied that. Minus 327682 plus 32767 for 8-bit. And okay, that is for 16-bit. That is for 16-bit. And for 8-bit byte, the range is minus 128 to 127. Okay, so these are the sign range. And for okay, they also talked about the unsigned range, but for overflow we don't count unsigned range. So unsigned range we only count for uh, carry flag. Carry flag is like unsigned overflow. Okay, so we studied the carry flag here. What did we study here? CF equal 1 if there is a carry out from the most significant bit on addition, or the borrow on the most significant bit on subtraction. That is actually unsigned overflow. CF equal 1 when there is unsigned overflow occurs. If you think about that, then you will understand. So carry flag equal 1 in unsigned overflow. And for sign overflow, overflow will become 1. And they also give the range of unsigned number, the range for word equals 0 to 65535, and the range for byte is 0 to 255. Okay, and that remember that does not affect the overflow flag, the range of unsigned number. The range of unsigned number affect the carry flag, and the range of signed number affect the overflow OF flag. Okay, then it said that if the result of an operation falls outside this range, overflow occurs, and the truncated result that is saved will be incorrect. So if you get a result outside this range, then overflow will occur, and the truncated results. Okay, so you can see if the result of an operation falls outside the range, then you will get the overflow. And the truncated মানে হচ্ছে সংকুচিত আমরা যখন ওভারফ্লো হয় তখন রেজাল্ট তো আউটসাইড অফ রেঞ্জ চলে যায়। সো ইন দ্যাট কেস আমরা যে রেজাল্টটা স্টোর করি সেই রেজাল্টকে বলা হচ্ছে ট্রাঙ্কেটেড রেজাল্ট, মানে সংকুচিত রেজাল্ট স্টোর করা হয়। আর এই ট্রাঙ্কেটেড রেজাল্টটা অ্যাকচুয়ালি নট কারেক্ট, বিকজ যেহেতু আমরা ট্রাঙ্কেটেড রেজাল্টটা হচ্ছে আউটসাইড রেঞ্জের রেজাল্টটা অ্যাকচুয়ালি স্টোর করতে পারতেছি না, So in that case, we can store the truncated result in the computer. So in case of overflow, we store the truncated result in the computer, and that is actually not correct. Okay, so let's see the example of overflow here. So we have example of overflow. Okay, what it said that, okay, so I already told you that unsigned overflow affects carry flag, and sign overflow affects overflow flag. Okay, let me ask it someone. Whom can I ask? Okay. Sabir Ahmed. Sabir Ahmed.
Yes, sir.
Okay, can you say that sign overflow affects which flag?
Sir, sign.
Sign overflow affects which flag?
Sir, it is affects the.
Okay, you can look at those flag and say, you can look at my screen. So there are flags. Okay, now say sign overflow affects which flag among those flag?
Sign overflow, sir. Carry flag.
And unsigned overflow affects which flag?
Sir, that is yes. Sir, status flag.
কি উল্টাপাল্টা কথা বলতেছেন, একটু আগে না বললাম।
আমি খাতায় উঠাইতে ভুলে গেছিলাম স্যার।
Okay, please say anybody.
Overflow
sign,
flag, sir.
Sir,
yes, sign overflow affects which flag?
wave flag, sir. Overflow
Wave
flag.
flag, overflow flag. And unsigned overflow affects?
Carry
Ronnie?
flag, sir.
Carry flag. Okay. Look, so sign overflow affects overflow flag, and unsigned overflow affects carry flag. Now, in example of overflow, it is said that signed and unsigned overflows are independent phenomena. They are not dependent with each other. Signed and unsigned overflow are independent from each other, because sign overflow occurs with sign number. When the numbers are signed, if you assume the numbers are sign number, then sign overflow may occur, and unsigned overflow occurs if you assume the number. We perform an arithmetic operation such as addition. There are four possible outcomes. There are four possible overflow may happen. So if you perform an arithmetic operation, then what are the possibility of overflow? First possibility, there will be no overflow, no sign overflow, no unsigned overflow. Actually, there is no overflow that may happen. So there is no sign overflow, no unsigned overflow. Case number one. The second case said the sign overflow only. So it may happen that there is only sign overflow and there is no unsigned overflow. The third case says that unsigned overflow only. So it may happen that there is only unsigned overflow and no sign overflow, because sign and unsigned overflow are totally independent of each other. They are not dependent on each other. So case number one, no overflow. Case number two, sign overflow only. Case number three, unsigned overflow only. And case number four says both sign and unsigned overflow. So when we perform an arithmetic operation, any kind of operation, whether it is addition, subtraction, multiplication, or division, so there are four possibilities of overflow. So first possibility, there is no overflow. Second possibility, there is only sign overflow. Third possibility, there is only unsigned overflow. And fourth possibility, your result may have both sign and unsigned overflow. That is the most complex one. So let's see an example of unsigned overflow here, but not sign overflow. There is only unsigned overflow. You can see here. We have 16.1, 16.1. That is in register X. the register X contains 16 1, and in register BX we have this number 0001. We have 0001 means all 15 zeros, then we have 1, that is in register BX. And we are performing this command add X, BX is executed. The binary result is 1111 plus 0001. And if we add those two, you'll get 000, all 16 0, and at the end you are getting a 1. So you can see from this, if you convert that to the decimal number, you can see that the this one, there are 16 that is in register X, that is actually 65535. And when you add 1, that means you are adding 1. So your result is basically 65536. That is your result. And in this result, you only get what kind of overflow? You only get unsigned overflow, because your result is out of the range of unsigned interpretation. So why it is out of the range of unsigned interpretation? Because you can see from MSB you have a carry 1, so carry flag will become 1 for this case, and there is no sign overflow. This is the only unsigned overflow. In this case we have only unsigned overflow. Okay, let's see how they are discussing this term. So if you look at their discussion in the book, so you can see if we are giving an unsigned interpretation, the correct answer is this one. This is the correct answer. Okay, we already said that 65536. You can see here we have written that. So if you give the unsigned interpretation, result is 10000 hex, that is 65536. But this is out of the range for a word operation. This is out of the range for a word operation. A 1 is carried out of the MSB, and the answer stored in X is 00. Actually, what answer stored in register X? Register X, we
Zero.
can only store 0, because 16 0, that is the range of register X. That means the storing truncated result is actually not correct, like it said here. If the result of an operation falls outside this range, overflow occurs, and the truncated result, truncated মানে হচ্ছে সংকুচিত result. So X actually আমাদের এখানে 4টা জিরো স্টোর করতেছে, 4টা জিরো হচ্ছে একটা truncated result that is saved will be incorrect. So that result is actually not correct result. So that's why we get unsigned overflow. That's why we get CF equal 1 for this case. Okay, so you can see the store result X equal 000, which is wrong. So unsigned overflow occurred. But stored result is correct for a signed number. Stored result is correct for a signed number. Why the stored result is correct for a signed number? I mean, why 0 is a correct result for a signed number? Let's see that why 0 is the correct result for signed number, and there is no sign overflow, OF equal 0. So this 0 result, stored result is 0, because X cannot store 1. 1 is the out of range. That is the bit number 16. Bit number 16 is out of range. In total, if you count bit 1 to, then it is bit number 17. But we always count bit from 0. That's why it is bit number 16. So X can only store up to bit number 15, 0 to 15. Okay, so why stored result 0? This is the stored result 0. Why it is correct for sign number? Okay, let's see that why it is correct for sign number. Because you know that in sign number, what is the value of this 16.1? Can you say what is the sign value of this 16.1? Anyone? What will be the sign value for 16.1?
In decimal, sir.
Yes, in decimal. What will be the
Minus
sign? Yes. say, say.
32768.
Very bad, very bad. So you always, the problem is, we studied this already in chapter 2, but you already forgot. So that is the thing. So you have to remember those things. So when you study something, so you should remember that. So tell me, what is the sign value for this 16.1? So we know that unsigned value is 65535. That is correct. But what is the sign value? I mean, we are getting the unsigned overflow because we are getting the result 65536, that is out of range. But, and that's why we are storing, the X is storing only 40. That is not correct. That's why we are getting unsigned overflow. But 40, you know, this 40 is correct for sign number. I mean, sign number result is 0, and actually storing the destination, actually storing the 0. Here destination is X, and destination is storing the result 0. That is correct. So why destination storing the result 0, and that is correct? To understand that, you have to know what is the value of sign number of 16.1. So what is the value of 16.1 in sign number?
Sir, -1.
Definitely, it should be -1. It should be -1. If there are 16.1, if there are 1001, if there are 2001, that is -1. That is -1 because how we know this is -1? You know that -1 is nothing but the 2's complement of +1. Okay, so -1. You can also check that in your calculator. If you write 32.1, then you get -1. If you write 64.1, then you get -1. 64.1 equal -1, 34.1 equal 32.1 equal -1. If you write 128.1, that also equal -1. If you write 4-bit 4.1, that is -1. In 8-bit, if you write 8.1, you get -1. That is the concept. And if you forget, you may forget that. So if you forget that, you always can apply 2's complement method, because you know that when you make 2's complement of +2, you get -2. If you make the 2's complement of -2, you get +2, vice versa, right? So if you make 2's complement of +2, you get -2. If you make 2's complement of -2, you get +2. So if you
আমাদের
forget
আনসাইন
that,
নাম্বারটা অলওয়েজ -1 হবে, -1 হবে।
বুঝে নেই, হ্যালো?
জি স্যার, বলতেছিলাম যে আমাদের তাহলে আনসাইন নাম্বারটা অলওয়েজ -1 হবে নাকি সাইন নাম্বারটার কথা বলতেছেন?
আনসাইন নাম্বার -1 হবে কেন? আনসাইন নাম্বার কখনো নেগেটিভ হয়?
না স্যার, সাইন নাম্বার স্যার।
আনসাইন নাম্বারের পার্ট তো আমরা অলরেডি বলছি, যেটা হচ্ছে 65536 রেজাল্ট।
জি স্যার।
আর 65536 রেজাল্টটা হচ্ছে অ্যাকচুয়ালি এক্স স্টোর করতেছে না। ডেস্টিনেশন কি স্টোর করতেছে? ডেস্টিনেশন 4টা 0 স্টোর করতেছে। ডেস্টিনেশন যেহেতু 4টা 0 স্টোর করতেছে, বাট ডেস্টিনেশনে স্টোর করার কথা কি ছিল? 140, রাইট?
হ্যাঁ স্যার।
ডেস্টিনেশন স্টোর করতেছে এইটা। এখন ডেস্টিনেশনে স্টোর করার আসলে কথা ছিল এইটা। তো এটা না স্টোর করে সে যেহেতু এটা স্টোর করতেছে, এটা তো আনসাইনের জন্য ইনকারেক্ট। ডেস্টিনেশনকে স্টোর করতে হবে 65536। এই জন্য আমরা এই যে ইনকারেক্ট রেজাল্ট পাইছি, এই জন্য তো আমরা এই যে সিএফ কে 1 করলাম, আনসাইন্ড ওভারফ্লো হয়েছে এখানে।
হ্যাঁ স্যার, বুঝতে পারছি স্যার।
ওকে, তাহলে এখন আমরা যখন সাইনে আসতেছি, দেখেন আপনার 2's কমপ্লিমেন্ট মেথড অ্যাপ্লাই করতে পারেন। যেখানে নাম্বারটা দেওয়া আছে, ওই নাম্বারের ভ্যালু যদি না বুঝতে পারেন যে এই নাম্বারের ভ্যালুটা অ্যাকচুয়ালি কত হবে, 16টা 1-এর নাম্বারের ভ্যালু আপনি সাইনে কত হবে জানেন, বুঝতেছেন না, সো তখন আপনি you can do the 2's complement of that number quickly to understand what will be the value of 16.1. So you can 2's complement করলে ফার্স্ট কমপ্লিমেন্ট করতে হবে আগে। এটা হচ্ছে ফার্স্ট কমপ্লিমেন্ট, দেন 1 অ্যাড করতে হবে। Okay, so that is the 2's complement. So if you make the 2's complement, you get all 0, you get 1. So basically you get decimal 1. So if you get decimal 1 in 2's complement, then this number should be -1 in 2's in decimal. That's why it is -1. Okay, you got it? So in sign number, it is -1, and the next number, this one is +1. So this is the second number is +1. So if you add this, your result is 0. Got it? So if the result is 0, and actually the register AX is also storing the result 0. That's why there is no sign overflow and OF equals 0. Okay, got it?
Yes, sir.
Okay, good.
Yes.
Okay, so we understand the sign overflow and unsigned overflow. Okay, if you look at their discussion, actually they have discussed the same thing. So let's see that. So what they are saying for sign case. Okay. Okay, so let's read the discussion for sign case. So for sign case, they are saying that what is sign case? Okay, but the stored number and answer is correct for a sign number because you know that FFFF equal -1 and 0001 hex equal 1, and that means FFFF H plus 0001 hex equal -1 plus 1 equal 0. So sign overflow did not occur. Sign overflow did not occur because destination is storing 0, and in sign number it is also 0. So you are getting the same result or the expected result. That's why there is no sign overflow happens. So for this number, okay, let's repeat the process again to understand it more clearly. If we are giving an unsigned interpretation, so we have two number here. First, there are 16 1, and second number 15 0 and 1. Then we add, we get x all 0, and we get a carry. Now, what is the explanation of that? If we are giving an unsigned interpretation, the correct answer is 10000 hex equals 65536. But okay, that is the correct result in unsigned interpretation. But this is out of range for a word operation. A1 is carried out of the MSB, and the answer stored in AX is 0000 hex. That is wrong. So unsigned overflow occurred. Okay, that is the unsigned part. So stored answer is wrong for unsigned case. That's why unsigned overflow occurs. CF will become 1. But the stored answer is correct as a sign number for FFFF H equal -1 and 0001 H equal +1. So you can add FFFF H plus 0001 H equal -1 plus 1 equals 0. So sign overflow did not occur. Okay, because the original result is 0 in sign case, and also register AX destination is also storing that original number minus 0. Original number 0. Okay, good. So let's see another example. So what we can find out in another example. Yeah. So okay. So as an example of signed but not unsigned overflow. So previous example, there is unsigned overflow. There is no sign overflow. There is only unsigned overflow. And you got CF equal 1 for previous example, and OF equal what? OF equal 0 for previous example, right? So yeah, so for previous example, you got CF equal 1 and OF equal 0. Now let's see another example. As an example of signed but not unsigned overflow. Now in next example, we'll see that the sign overflow occurs, but unsigned overflow does not occur. The opposite. So sign overflow, there is sign overflow, but there is no unsigned overflow. Suppose AX and BX contain 7F and 7F. So what it said, suppose AX and BX both contain 7F and 7F. So AX contains AX and BX both contain 7F, FF hex, and we execute ADD AX, BX then you get what? FFFE, that is my result. Is there any carry out from the MSB? What do you think? Is there any carry out
No,
from the
sir.
MSB? There is no carry out from the MSB. Okay, good. So there is no carry out from the MSB. That is correct. There is no carry out from the MSB. Yeah. Okay. So now look at here. So if I tell you, so yeah. So if I tell you, so this is the first number. What is the value of this first number in decimal? What is the value of the first number in decimal? Can you say what is the value of the first number in decimal?
Three two seven 6 7.
3, 2, 7,
7 6 7.
6, 7. Okay, that is the value of the first number. And what is the value of the second number?
Same, sir.
So that is also 3, 2, 7, 6, 7. So we have two number here, 32767 plus 32767. If we add those, then what is the value in decimal? If you add those, what will be the value in decimal?
65534.
6, 5, 5, 3, 4.
34.
So what do you think? 65534 is out of unsigned range or within the unsigned range?
Within.
Hey, out of ke bolde?
Sir,
Within, sir. Within the unsigned range.
So 65535 is within the unsigned range. That's why, what do you think? Is there an unsigned overflow for this case? Yes?
No, sir.
No, sir.
Okay, so there is no unsigned overflow for the second case. So CF equal what? Sign 0 or 1? CF is the carry flag. Carry flag equals 0 or 1?
0, sir.
0, exactly. So carry flag equals 0. Now, if I
No,
ask
sir.
you, yeah, now if I ask you, so there is no unsigned range. That is totally correct. So you're right. That is correct. So now if I ask you, is there any sign overflow occurs? What will be your answer? What will be your answer if there any sign overflow occurs?
Sir, no sign flow occur.
Why?
স্যার সাইনে তো হওয়ার কথা স্যার, সাইন ওভারফ্লো অকার।
সাইন ওভারফ্লো কেন হচ্ছে না বলেন? Okay, so what is the first number in sign number? If you consider the first number in sign number, what will be the value? First number in the sign number, what will be the value? The first number in case of sign number, what will be the value of the first number? This is this number. What is the value of this first number in case of sign number? Can you say? Value of the first number in case of sign number? Okay. Can you say that? Okay. Hey, anyone, what is the value of first number in case of sine number? Anisul Azam. Anisul Azam?
Yes, sir.
Yes, sir. What is the value of first number in case of sine number? Okay, who can say?
-1, sir.
Aminul,
Yes, sir.
tell me, what will the value of first number in case of sine number?
স্যার -32768
কেন হবে -22768? কি দেখে ওটা আসলো বলেন দেখি একটু ভালো করে বুঝাই বলেন। কোথায় থেকে
স্যার সাইন নাম্বার তো এটা থেকেই শুরু হইছে।
Okay, say. Hey, you cannot see that MSB is 0 here. MSB 0 means this number is positive. When you calculate the sign interpretation, MSB 0 means number is positive. You already know that. Why cannot you remember that? So MSB is 0 here. Here also MSB is 0. So both number are positive numbers. And you know that for positive number, what is the value of sign value? Equal the same as the unsigned value. So positive number, the sign value is same as the unsigned value. How can you forget that? 32767. The second number is also same. Second number also 3276. 32767. Why those numbers are same for signed case and unsigned case? Because both numbers are positive. MSB is 0. So when the number is positive, whatever the sign value, the unsigned value is also same as the sign value. So its sign interpretation also, its unsigned, yeah, its unsigned interpretation is 65535, and its sign interpretation also 65535. Sorry, it's 34. So add those two. What will be the sign interpretation? 65534. That is also the sign interpretation. Unsigned interpretation, sign interpretation, both same. 65534. That is what they said. Look, the sign and unsigned decimal interpretation of 7 FFFF is 32767. এটার কথার মানে হচ্ছে যে এই নাম্বারটা হচ্ছে সাইন নাম্বারেও যেটা, আনসাইন নাম্বারেও সেটাই। The sign and unsigned interpretation. আগের কোশ্চেনে কিন্তু সাইন ছিল -1 আর আনসাইন ছিল কত? 65535। আর এখানে কি বলতেছে? এখানে বলতেছে যে সাইন আনসাইন both interpretation is same. So that means এখানে আমাদের এখানে হচ্ছে আমাদের আনসাইন এখানে আমাদের হচ্ছে 3 কত? আনসাইন হচ্ছে 32767, আর আমরা যদি সাইনে আসি তাহলেও হচ্ছে ওটাও হচ্ছে 32767। সো সাইন আনসাইন দুটাই হচ্ছে 32767 বোথ ইন্টারপ্রিটেশন। কেন দুটাই 32767? কারণ হচ্ছে এখানে MSB 0, ইমেজি জিরো মানে হচ্ছে পজিটিভ নাম্বার, পজিটিভ নাম্বার হচ্ছে সাইন অফ যেটা সেটা আনসাইন হচ্ছে সেটাই। এবার বুঝতে পারছেন? Okay, do you understand? ইফাত, ইফাত, ইফাত
Yes, sir.
বলেন, এখন বলেন রেজাল্ট তাহলে সাইনে কি হবে, আনসাইনে কি হবে? What will be the result in sine and what will be the result in unsign?
Sir, here both are same.
Both are same. Same মানে কত? Both কত? What should be both?
Sir, 3 to 7, 6, 7.
3 to 7 6 7, 3 to 7 6 7 যোগ করলাম, তাহলে দুটার রেজাল্ট কি হলো? সাইনে কি হলো, আনসাইনে কি হলো?
Sir, 6, 5, 5, 3, 4.
ওকে, তাহলে 6 5 5 3 4 এটা হচ্ছে আনসাইনের জন্য কারেক্ট না ইনকারেক্ট?
Sir, correct, sir.
ওকে, আনসাইনের জন্য কারেক্ট, এই জন্য আমরা CF0 পাইছি। ঠিক, ওকে ঠিক আছে। তারপরে তাহলে এখন বলেন এই না এর রেজাল্টটা কি সাইনের জন্য সেম না কারেক্ট না ইনকারেক্ট 16 বিটে?
Sir,
এটা
16 bit
এটা
sir. এখানে
এটা হচ্ছে
1
রেজাল্ট।
আছে তো স্যার এটা নেগেটিভ হবে।
নেগেটিভ হবে, রাইট? তাহলে নেগেটিভ কত হবে এটা বলেন দেখি। এইটা নেগেটিভ। হ্যাঁ বলেন।
6, 5, 5, 3, 4.
-65534 কেন হতে যাবে? ওটা আপনাকে হিসাব করে বের করতে হবে। হিসাব করে বের
স্যার
করেন।
হিসাব করে বের করতে হবে। জি স্যার।
তো হিসাব করে বের করেন, বের করে বলেন। কথা আসছে বলেন প্লিজ সে। Hi, Tasneem, Hussain, Rafi. Tasneem?
Yes, sir.
Tasneem.
Yes, sir.
So, did you get the result? Sign. What is the sign value for the result?
No, sir. I'm trying, sir.
Sir, sign value maybe -2, sir.
Yeah, so you have to make 2's complement. It's very simple. How you cannot get it? So you have to make 2's complement. So 1 1 1 1 1, then 1 1 1 1 1 0. Then 2's complement
0 0 0 0.
0, then 0 0 0 0 0 0 1. Then you have to add 1. So you get 1 0, right?
Yes.
1 0 in decimal equal 2. So that means it is -2. So that is the -2 in 16 bit. But the result is not actually -2. Result is basically 65534 in sign also. Okay. Because these two are positive sign number. These two are positive sign number. But you get result negative -2. How on earth it is possible that result is -2? If you add two positive number, you get result -2. How it is possible? It is really a impossible thing, right? You are adding two, adding two positive number and you are getting a result negative number. It is not possible in real life. It is only possible in sign number in computer. Yeah. So if you count 32 bit, it should be 65534, and you can store the exact result in 32 bit. But in 16 bit, you cannot store the exact result. Rather, you have to store the -2 in 16 bit. That's why there is sign overflow, because in 16 bit it is not possible to store 65534 for sign number, because you have to put MSB 0. How can you put MSB 0 here? It is not possible to put MSB 0 in 16 bit. You have to go to 32 bit, right?
Yes, sir.
So that's why the interpretation is incorrect. Sign interpretation is 65534, that is incorrect. Unsigned interpretation is correct, 65534. But sign interpretation is incorrect. That's why you get OF equal 1. Six five five 34. But this unsigned result, it is correct, because if you calculate this value in unsigned case, that is actually 65535. So this, it's storing the correct result in unsigned interpretation. But if you calculate this signed value, it is storing actually -2, and it should store 65534. But in 16 bit, it is not possible to store 65534. It is only possible if you go to the 32 bit, because you have to make MSB 0. And MSB 0, you can make that if you go to the 32 bit register. that is not available in 8086 32-bit register. 32-bit register, you can also emulate that. So that is EAX. There are 32-bit processor, and we have EAX, not AX, but EAX register. In 8086 is AX register, and EAX, that is 32-bit register. So if you store this result, FFFE, 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 H, that is in 32-bit register EX, then you get MSB0 here, because there are 40 here. So there are 40 here. So you get MSB0. In that case, you get the same result as sign interpretation 65534. So in that case, it will be correct and overflow will not occur. So overflow is the terminology. It is there because due to the limitation of the computer memory. So that's why the overflow is there. So it's this terms actually comes into its existence due to the limitation of the computer memory. It is overflow occurs for OF overflow occurs for 16-bit registers for 8086 processor, but if you go to the 32-bit processor and if you use EX register, then the overflow will not occur. Okay, so in that case, overflow will not occur. Okay. So then what can we discuss? Okay, so that is what I'm like to talk. So OF equal 1 here, and CF equal 0 here. So because overflow occurs, the actual storing result is -2, but it's not correct. It should store this number, it cannot store in 16-bit register. So if you read that, their explanation, what they have written here, what is their explanation? So okay, the sign and unsigned decimal interpretation, sign, unsigned both. So this is the positive number. Positive number, sign, unsigned, always same. Remember that. So sign and unsigned decimal interpretation is 7 FFF equal 32767. Thus, for both sign and unsigned addition, you get for both sign and unsigned. Look. So now the number is always same. Say 7FF equal 3276 plus 3276 equals 65534. This is out of range for sign number. The sign out of range because 65534 is the out of range of 16 bit because it is only -32767 to -32768 to plus 32767. That's why it is out of range. This is out of range for sign number. The sign interpretation of the stored result is actually -2. That is not correct. So sign overflow occurs. However, the unsigned interpretation FFE equals 65534. This is the right answer. That's why there is no unsigned overflow. There are two questions to be answered in connection with the overflow. How does CPU, central processing unit, how does central processing unit indicates overflow? That is the first question. And second question, how does it know that overflow occurred? So these are the two questions we are going to answer now. So how does CPU indicate overflow? That is the first question. How does CPU indicate overflow? CPU কিভাবে overflowটা indicate করে, indicate মানে কি চিহ্নিত করা, right? Okay, how does CPU indicate overflow? And the second question, how does it know that overflow occurs? এবং CPU কিভাবে জানতে পারে যে আসলে overflow হয়েছে? So let's talk about that. Okay, so how does processor indicate overflow? That is the how the processor. Okay, these are the two questions we are going to answer. So how does the first question, how does the processor indicate overflow? So the processor sets wave equal 1. Okay, I already discussed that actually. So the processor sets wave equal 1 for sign overflow and CF equal 1 for unsigned overflow. It is then up to the program to take appropriate action. It is then up to the program to take appropriate action. And if nothing is done immediately, the result of a subsequent instruction may cause the overflow flag to be turned off. If nothing is done immediately, the result of a subsequent instruction maybe cause the overflow flag to turn on. Suppose if you have suppose your overflow flag become 1, but in the next time you're doing another operation, and that operation may affect the overflow flag also, because overflow flag may change. That is what it is saying. In determining the overflow, the processor does not interpret the result as either signed or unsigned. Processor does not interpret the result as either signed and unsigned. The action it takes is to use both interpretation for each operation. So if you can check that. So if in an emulator, if you write some instruction for 8086 processor, emulator is for 8086 processor, and if you write some instruction, they consider both sign and unsigned overflow together for a number. So it will show the sign overflow, it will show the unsigned overflow. Both case they will consider together, because they consider a number signed number. They also consider a number unsigned number, because you don't know actually whether this number is signed number or unsigned number. So if you consider the number is a signed number, then sign overflow may occur. If you consider the number is an unsigned overflow, then unsigned overflow may occur. So that's why CPU always consider the number at signed and unsigned together. Both interpretation is taken into account. So in determining the overflow, the processor, what this is, the processor does not interpret the result as either signed or unsigned, as either signed or unsigned. মানে হচ্ছে একটা করে নাই না. So the action it takes is to use both interpretations. Look, so use both interpretation for each operation, and to turn on CF and WF for unsigned overflow or signed overflow respectively. So CPU always যেটা নেয় সেটা হচ্ছে দুটো ইন্টারপ্রিটেশনই সবসময় কাউন্ট করে, সাইন ইন্টারপ্রিটেশনও কাউন্ট করে, আনসাইন ইন্টারপ্রিটেশনও কাউন্ট করে। কিন্তু আমাদের কিন্তু সাইন ইন্টারপ্রিটেশন আনসাইন ইন্টারপ্রিটেশন দুইটা দরকার হয় না অনেক সময়। কেন? কারণ হচ্ছে যে if you take the number as a signed number, then you will consider the signed thing. If you take number as unsigned number, then you will consider the number is the unsigned number. So it is the programmer, that is what it's saying. It is saying next, it is the programmer who is interpreting the result. It is the programmer who is interpreting the result. If a sign interpretation is being given, only wave is of interest. If a sign overflow, if you consider the sign overflow only, then you only look at the wave overflow flag, and CF can be ignored in that case. Conversely, for an unsigned interpretation, if you only take the account of unsigned overflow, then CF is important but not OF, because OF is for signed overflow. Okay, so how does processor indicate overflow? That is what we know. Then how processor determines that overflow occurred? Many instructions can cause overflow. For simplicity, we will limit our discussion in addition and subtraction. So in this chapter, for simplicity, we are limiting our discussion in addition and subtraction. But in our later chapter, we'll discuss also other operation like multiplication, division, sign multiplication, sign division, unsigned multiplication, unsigned division, this kind of thing. So let's talk about sign overflow in more details. So unsigned overflow. Unsigned overflow and sign overflow. Okay, so unsigned overflow, what it says. So on addition, unsigned overflow occurs when there is a carry out of the MSB. I already told you that. This means that the correct answer is larger than the biggest unsigned number. The correct answer is larger than the biggest unsigned number, that is FFF for a word and FF for a byte. So if you work with a word, then FF is the highest number and your correct answer may be more than that. If you work with a byte, then the largest unsigned number it can store is FF, and your unsigned result may be more than that. And on subtraction, unsigned overflow occurs if there is a borrow into the MSB. This means that the correct answer is smaller than 0. So when you get borrow, if the subtracted number is greater, if you subtract bigger number from the lower, if you subtract the bigger number is +7. If you subtract +7 from +2, then you'll get result -5. So that means if your result is in also minus direction, then you get unsigned overflow. So your minus unsigned case number is 0. So if your result is negative, in that case also you get unsigned overflow, because unsigned range is 0 to FFFF for F, or 0 to FF for byte and word and byte. Then sign overflow. So what it says in sign overflow, it is a little bit tricky. Unsigned overflow is very simple. Sign overflow is a little bit tricky, and it affects the web flag. So we'll understand some tricks here. How can you easily find the sign overflow rather than making two's complement and all those calculations? So let me tell you the trick here. So you are adding two positive numbers. You are adding two positive number. That, how can you know where you are adding two positive number? Can you say that? How can you know that you are adding two positive number here?
MSB is 0.
Exactly. So MSB is 0. So you are adding a positive number. This MSB also 0. You are adding another positive number. Suppose if I tell you that positive number can be anything, any positive number. Suppose positive 5. You are adding positive 5, and there is another plus you can see here. That means you are adding. So this plus indicates you are adding. So you are adding another number. So another second number is also positive. So positive 12. So two positive numbers you are adding. So what will be the result? Positive or negative? Positive result should be positive, definitely. So it is never in this earth, it is not normal that you are adding two positive number, you are getting a negative result. Can you give an example of that? So suppose if you are adding two positive number, you are getting a negative number. Is there any example of that?
Maybe no, sir.
Maybe no, but
There is no example.
yeah, but it is possible in computer. What this number is negative or positive? What do you think?
It's negative.
Why?
MSB, sir, MSB is 1, sir.
MSB is 1. Look, you don't have to make 2's complement. You don't have to see the exact what is the value. That is -2 actually. So you don't need to see that. You just need to know the sign. So positive number added with positive number, another positive number. Then you are getting a negative number. Instantaneously, you can say that overflow flag equal 1. Because it is not normal. How on this earth you are getting a negative number by adding two positive number? It is not possible. It is not normal, right? It is not the normal case. It is the abnormal case. So that's why you can immediately say there is sign overflow occurred. You don't have to calculate anything. So that is the trick or shortcut. So you can immediately say that is okay. We have sign overflow because we are adding two positive number and we are getting a negative number. That does not seem normal. So there is sign overflow. So overflow flag will definitely become 1. Okay, so that is this kind of trick we'll learn here in this section. Let's go there. Here, so sign overflow. So on addition of number with same sign, if you add number with same sign overflow occurs when sum has a different sign. We just gave an example of that. On addition of number with the same sign overflow occurs when sum has a different sign. That may not be only positive, it may be also negative. Okay, so suppose you have positive number. We see the example for positive number, positive plus positive. Okay, positive A, just write positive A. Positive A plus positive B, and you get negative C result. You immediately know that overflow occurs, and you have to look at the MSB for that to understand that. Suppose you add negative A plus negative B, so you get positive C. So immediately you can say overflow occurred. Why? I added two negative number. How can I get positive result? That is not possible in normal case. That is only possible for sign number. Okay, so that is what it said actually. So on addition of number with same sign, signed overflow occurs when sum has a different sign. Okay, so if the sum has a different sign, then sign overflow occurs. You can just keep remember these two line, and just remember that if you add two positive number, you should get positive result. If you add two negative number, you should get negative number. Okay, this happens in the preceding example as we added. Okay, they're talking about the example we have given. So this happens in the preceding mani purvavarti preceding example when we were added 7 triple f hex and 7 triple hex to positive number and got a negative result. Okay, so that is the shortcut trick. So now addition is complete. Now let's talk about subtraction. The subtraction of numbers with different sign. Subtraction of number with different sign is like adding number with the same sign. Subtraction of number with different sign is like adding number with the same sign. So for example, এখানে আমাদের দেখেন দুইটা এক্সাম্পল দেওয়া আছে। এই এক্সাম্পল গুলো কি দিচ্ছে দেখেন আমি আপনাকে বলি। সো এখানে subtraction of number. So we are subtracting a minus b. So subtraction of number with different sign. A is the positive number. You can see B is the negative number because there is minus B. How can we write that? So we can write that like this way. A minus B, we can write that A plus B, right? Minus plus, you know. So then A plus B, so it falls in the rule number 1. So if it is the rule number 1, it falls in that category. How? Because you can see A plus B, so you can write that plus A plus B, right? So if you get result minus C, then there will be overflow. If you get result plus C, then there will be no overflow. So look, so when you subtract, subtraction can fall in the addition rule. How? Subtraction A minus B, different sign subtraction. This is the same sign addition. Look, same sign addition. So subtraction of number with different sign can be fall like the same sign addition. So if you get A minus B, so you can write A plus B. So you can write plus A plus B. And then you can write, if the result is minus C, you get overflow. If the result is plus C, there is no overflow. And there is second example. Look at here. So it says that minus A, this is the negative number, minus plus B. So negative এর কাছ থেকে আমরা পজিটিভ বি এর বিয়োগ করতেছি। এটাকেও কিন্তু আমরা অ্যাডিশনাল রুলসে নিয়ে যেতে পারি। কিভাবে? এই যে দেখেন এখানে আমরা মাইনাস এ কে রাখবো এখানে, আর এই যে প্লাস বিটা, প্লাসটাকে বাইরে নিয়ে আসবো আর মাইনাসটাকে ভিতরে নিয়ে যাবো। তো প্লাসটা বাইরে চলে আসলো আর মাইনাসটাকে নিয়ে গেলাম ভিতরে, তাহলে কি আসলো? এই যে দেখেন 2 নম্বর রুলস এর মধ্যে পড়ে গেছে অলরেডি। সো 2 নম্বর রুলসে কি বলতেছে? মাইনাস এ প্লাস মাইনাস বি, if the result is minus C, then no overflow. If the result is plus C, then there is the overflow. Okay, so and that is what it is saying here. So subtraction of number with different sign is like adding the number with the same sign. For example, if we, for example, A minus B equal A plus B, and minus A minus plus B equal minus A plus minus B. Sign overflow occurs if the result has a different sign than expected. See example 5.3. So we have the example 5.3. We'll see that later. So then we have addition. In addition of number with different sign. In addition of number with different sign. You know, when you add number with different sign, there will be no overflow. Why there will be no overflow? Because if you add number with different sign, that means, suppose, let me give you an example. So if you add number with different sign, suppose +7, one is +7, and adding with negative, whatever, -2, -10, negative, whatever the number, -10, suppose. So adding number with different sign, overflow will not occur. Why? That means OF equals 0. So why adding number with different sign, OF equals 0? Because if you add number with different sign, then what will happen? Then if we add number with different sign, you'll always get a smaller result. You always get smaller result, because you get result -3, that is small than small, right? You will always get a smaller result, -3. Yeah. So in addition of number with different sign, overflow is impossible. Overflow is impossible. That is what it said. Overflow is impossible. Overflow is not possible, because sum a plus minus b, a plus minus b is really a minus b, because a and b are a and b are small enough to fit in the destination. Now that we are adding the numbers, so you can write that like 7 minus 10, or 7 minus 10. Yes, 7 minus 10. You can write that. Yeah, 7 minus 10 equal -3. That is the result. So you know that as already 7 and 10 are fit in the destination, then overflow is impossible, because the result is always less, and that would also fit in the destination. 7 and 10 is fitting in the destination, result is less, destination and source. So result is less than that, and that will always fit in the destination or source, whatever you say. That is what it is saying. So because the sum like a plus minus b is really a minus b, because a and b are small enough to fit in the destination, so a minus b. So because a and b are small enough to fit in the destination, so is a minus b. For exactly the same reason, subtraction of number with the same sign cannot give overflow. So addition with number with different sign, remember that addition with number with different sign cannot give overflow. Subtraction with number with the same sign cannot give overflow, because your result will be always less than the current number. Current number is this and this, so your result is -3. 3 is always less than the correct 7 and 10. So addition of number with different sign cannot give overflow. Addition of number with different sign cannot give overflow. Subtraction of number with same sign cannot give overflow. In these two cases, there will be no overflow. Okay, is it clear up to this? What do you think? Hello? Hello?
Yes, sir.
Okay, is it clear up to this? Okay, so let's check. So what is next? Okay, so there is some more of what it said. Actually, the processor uses the following method to set the overflow. If carries into and out of the MSB don't match, if the carries into and out of the MSB don't match, that is, there is a carry into the MSB but not carry out, or if there is a carry out but no carry in, then sign overflow has occurred, wave is set to 1. Okay, I hope you understand. Okay, so next how instruction affects the flag. Okay, কিভাবে instruction গুলা flag কে হচ্ছে affect করে. So আমাদের so in our chapter 4, so can you remember those instruction we studied in chapter 4? What are the instruction we studied in chapter 4? MT Hafiza, MT, can you say what are the instruction we studied in chapter 4?
Yes, sir.
Yes, tell me, what are the instruction we studied in chapter 4?
স্যার
Yes.
চ্যাপ্টার 4 স্যার ডেস্টিনেশন সোর্স এইগুলো স্যার
No, instruction, assembly instruction. What are the assembly instruction we studied in chapter 4?
চ্যাপ্টার 4
Yeah.
স্যার একটা একটু মনে করাই দিবেন স্যার
মনে করো ট্রাই করেন, what are the instruction? Who can say?
Sir,
Sir, move exchange.
এই আপনারা যে একটা চ্যাপ্টার পড়ে আসলেন, যে চ্যাপ্টার 4 পুরোটা পড়ে আসলেন, পড়ে এসে যদি এখন এটাই যদি না বুঝতে পারেন যে কি ইনস্ট্রাকশন পড়ে আসছেন, তাহলে কেমনে হবে? হাউ ইট উইল ওয়ার্ক? যে চ্যাপ্টার 4 পুরোটা পড়ে আসলেন, পড়ে এসে এখন বলতেই পারছেন না যে চ্যাপ্টার 4 এ কি কি ইনস্ট্রাকশন পড়ে আসছেন। চ্যাপ্টার 4
স্যার ইনক্রিমেন্ট ডিক্রিমেন্ট স্যার অ্যাডস সাবট্রাকশন দেন এক্সচেঞ্জ স্যার এইগুলো স্যার অ্যাকচুয়ালি এগুলো
ওকে, সো এই যে চ্যাপ্টার 4 এ আমরা চলে আসছি। সো চ্যাপ্টার 4 এটা আপনাদের না পড়তে বলছি, এই চ্যাপ্টার পড়েন নাই কেন? এখানে এই যে অ্যাসেম্বলি সিনট্যাক্স, হ্যাঁ আপনারা পড়ছেন অনেকে, এবার অনেকে পড়ে নাই। তো এই যে এখানে যে সিনট্যাক্স গুলো আমি পড়তে বলছিলাম, তারপরে এই যে নেম কনস, এগুলো তো আমরা সবই ডিসকাস করছি, এমন কোনো জিনিস নেই যে ডিসকাস করা হয়নি এখানে। সো ইফ ইউ স্টাডি দিস চ্যাপ্টার দেন ইউল আন্ডারস্ট্যান্ড। ওকে, সো ইউ হ্যাভ টু স্টাডি দ্যাট। এই যে এখানে অ্যারে চলতেছে, এটা কি অ্যারে? বাইট অ্যারে। তারপরে এই যে এটা কি? ওয়ার্ড অ্যারে। ইয়েস, ওয়ার্ড অ্যারে, ক্যারেক্টার স্ট্রিং। তারপরে এই যে ইকুয়েটস নেম কনস্ট্যান্ট, এগুলো তো আমরা ডিসকাস করছি। তারপরে এই যে এটার মাঝখানে এই যে দেখতেছেন যে এই যে নিউ লাইনে যাওয়ার পরও আছে লাইন ফিট। এটা লাইন ফিট নাকি এলএফ? হ্যাঁ, এই যে লাইন ফিট আছে, লাইন ফিট। এই যে ও এ মানে হচ্ছে এটা তো ইয়া হয়ে গেছে আর কি, ইকুয়েটস, লাইন ফিট, ক্যারেজ রিটার্ন সব আছে এখানে। এই যে ইনস্ট্রাকশন শুরু হলো, মুভ, এক্সচেঞ্জ। এখানে কি লেখা? এ ফিউ বেসিক ইনস্ট্রাকশন, এ ফিউ বেসিক ইনস্ট্রাকশন, মুভ এন্ড এক্সচেঞ্জ। দেন এই যে আমরা এই কম্বিনেশন গুলো তো করছি, মুভ, এক্সচেঞ্জ। তারপরে এখানে চললো ইন অ্যাড, সাব, ইনক্রিমেন্ট, ডিক্রিমেন্ট, নেক, এগুলো তো করলাম আমরা। সো এই ইনস্ট্রাকশন গুলোর কাজ ওখানেও আছে, চ্যাপ্টার 5 এও আছে, ঠিক আছে? সো এটা চলতেছে। এই যে আমরা এখানে ক্যারেক্টার মুভ করলাম, ক্যারেক্টার এই ক্যারেক্টার মুভ করলাম। ওকে, তারপরে এই যে ট্রান্সলেশন করছি আমরা, স্টেটমেন্ট কিভাবে লেখে, প্রোগ্রাম স্ট্রাকচার, আমরা তো প্রোগ্রাম স্ট্রাকচার পড়ছি। এই যে স্মল মডেল, এই যে এখানে দেখতেছেন না যে স্মল মডেল, মিডিয়াম মডেল, কম্প্যাক্ট মডেল, লার্জ মডেল, হিউজ মডেল। আজকে আমরা স্মল মডেল নিয়ে কাজ করলাম। তারপরে এখানে এই যে ডেটা, ডট ডেটা লিখতে হয়, এটা আজকে আমরা দেখছি যে ভ্যারিয়েবলের সাথে। এই যে এখানে দুটো ভ্যারিয়েবল, 4টা ভ্যারিয়েবল অ্যাসাইন করছে। একটা হচ্ছে ওয়ার্ড ভ্যারিয়েবল, দুটো ওয়ার্ড ভ্যারিয়েবল, পরেরটা হচ্ছে বাইট ভ্যারিয়েবল, আর একটা হচ্ছে কনস্ট্যান্ট মাস্ক। তারপরে এই যে স্ট্যাকে আমরা সাইজ মেনশন করি। এগুলো তো নিজে নিজে পড়তে হবে, এত কিছু পড়ানো পসিবল নেই। সো স্ট্যাক, এই যে স্ট্যাকের সাইজ দিয়ে দিলাম। তারপরে যে কোড শুরু হলো, তারপরে যে বডিটা এইভাবে আসতেছে, মেইন প্রক, তারপরে এখানে বডি গেল, দেন এন্ড মেইন, প্রোগ্রামটা শেষ হলো। তারপরে এই যে চলতেছে প্রোগ্রাম। এই যে তারপরে এই যে দেখেন এখানে প্রোগ্রামের স্ট্রাকচার, মেইন স্ট্রাকচার এটা দেওয়া আছে। এটা হচ্ছে সবসময় সেম, অলওয়েজ সেম। ডট মডেল ইজ স্মল, ডট স্ট্যাক 100 ইজ, ডট ডেটা। এই যে ডট ডেটার পরে এখানে ভ্যারিয়েবল চাই। এই যে এখানে কি বলতেছে, ডেটা ডেফিনেশন গোজ হেয়ার। তো ডেট ডেটার পরে আপনারা চাইলে ডট কোড লিখতে পারেন। এটা ডট কোড লেখার পরে মেইন পিআরওসি প্রক মানে মেইন প্রসিডিউর শুরু হলো। তারপরে এখানে ইনস্ট্রাকশন যাবে, ইনস্ট্রাকশন যাওয়ার পরে এখানে হচ্ছে মেইন এনপি মানে মেইন প্রসিডিউর শেষ হলো। এখানে যদি আদার কোনো ইনস্ট্রাকশন লিখতে চান সেটা এখানে লিখতে পারেন, না হলে এন্ড মেইন, তার প্রোগ্রামটা শেষ। তারপরে এগুলো সবকিছু মিলে এই যে এখানে এন্ড মানে হচ্ছে ইন্টারাপ্ট। তো এখানে আমরা বিভিন্ন ধরনের ইন্টারাপ্ট 21H নিয়ে যে আলোচনা আছে, বিশদ আলোচনা। N21H আমরা এটা ওকে কেন ইউজ করি, আপনারা দেখছেন যে যে কোনো প্রোগ্রাম আসলে যে কোনো লাইন যে কোনো মানে অপারেশন লেখার পরে আমরা এন্ড টু এন্ড টু ওয়ান এইচ দিয়ে সেটা শেষ করি আর কি। সো এই যে সিঙ্গেল কি ইনপুট, সিঙ্গেল ক্যারেক্টার ইনপুট, ক্যারেক্টার স্ট্রিং আউটপুট। এই যে এখানে প্রবলেম হচ্ছে এখানে তারা ডবল ক্যারেক্টার, আজকে যেটা আমরা দেখছিলাম 10-20 ডবল ক্যারেক্টারের কোডটা দেওয়া নেই এখানে, ওটা আপনারা নেটে সার্চ করে দেখেন কি আছে। আমরা সিঙ্গেল ক্যারেক্টারের কোড দিয়ে আমরা আজকে দেখছিলাম, এই জন্য ওখানে 10টা আসে নাই আর কি। সো এই যে সিঙ্গেল ক্যারেক্টারের ইনপুটের জন্য এটা কোড মুভ এজ, 1 and 21 is, আজকে আমরা এটা দেখছি। তারপরে এই যে 2 দিয়ে হচ্ছে এটা ডিসপ্লে করে, এই যে 2 দিয়ে আউটপুট, এটাও আমরা দেখছি আজকে। মুভ এজ, 2 and 21 is, এই ক্যারেক্টার ডিসপ্লে করতেছে 2 দিয়ে। এগুলা কিন্তু ডিটেলস এই চ্যাপ্টার 2 এ চ্যাপ্টার 4 এ এগুলো ডিসকাস করা ছিল। সো এগুলো চলতেছে যে এখানে বিপ সাউন্ড দিবে, এটা 7 রান করলে। তারপরে এই যে এখানে দেখেন প্রোগ্রামিং এর সবগুলো একসাথে নিয়ে আসলো। এটা হচ্ছে রিড, ক্যারেক্টার রিড করার জন্য এটা দেয়, এন্ড মুভ এজ, 1 and 21 is। তারপরে মুভ এজ 2 and 21 is, এটা ক্যারেক্টার হচ্ছে প্রিন্ট করার জন্য। তারপরে এই যে মুভ এজ, 2, এটা নিউ লাইন প্রিন্ট করার জন্য, আজকে এটা আমরা দেখলাম নিউ লাইন গেল। তারপরে এখানে এই তো এগুলো দিয়েই এগুলাই চলতেছে। তারপরে এখানে যে একটা প্রোগ্রাম দেখাচ্ছে তারা, এটা আপনারা রান করে দেখতে পারেন চাইলে। এখানে একটা প্রোগ্রাম দেখাচ্ছে, একই জিনিস ওই। তারপরে এই যে প্রোগ্রাম চলতেছে রান দ্য প্রোগ্রাম। এই যে ডিসপ্লে কোড চলে আসছে এখানে। এই যে দেখেন এখানে কি বলতেছে, লি লোড ইফেক্টিভ অ্যাড্রেস, এটা আজকে আমরা ডিসকাস করছি। তো লোড ডেস্টিনেশন সোর্স, ডিএক্স এ নিতে হয় ওটা। তারপর এই যে শুরুতে যেটা ডেটা ডেফিনেশন অ্যাসাইন করলে মুভ এক্স @data মুভ dsx, এই যেটা আমরা লিখছিলাম আজকে। তারপরে এখানে এই যে লোড ইফেক্টিভ অ্যাড্রেস, যে মেসেজটা দিলাম ওই মেসেজের লোড ইফেক্টিভ অ্যাড্রেস এবং মুভ এক্স, এটাও আমরা দেখছি আজকে। ওই যে ভ্যারিয়েবল এক্স কে দেখালাম এইভাবে। তারপর এখানে আর একটা প্রোগ্রাম আছে, এটা পড়বেন নিজে। তারপরে যে একটা কেস কনভার্সন প্রোগ্রামও আছে। এই যে আমরা বলছিলাম যে লাইন ফিট ক্যারেজ রিটার্নকে যেমন নিউ লাইনে যাওয়ার কোডকে এভাবেও লেখা যায় CRLF দিয়ে। ওডি মানে হচ্ছে 13 আর ওয়ে মানে হচ্ছে 10। সো আমরা এইভাবে লিখতে পারি। যেমন এখানে দেখেন মেসেজ 1 দিচ্ছে, মেসেজ 1 এর পরে এখানে CRLF এখানে অ্যাসাইন করে এখানে CRLF দিয়ে দিল, তার মানে এটা হচ্ছে নিউ লাইনে যাবে। এই সেকেন্ড মেসেজটা নিউ লাইনে যাবে। তো এটা ফার্স্ট লাইনে যাবে ইন্টারেল ওয়ার্কেস লেটার, আর সেকেন্ড মেসেজটা নিউ লাইনে যাবে, সেকেন্ড লাইনে যাবে, কারণ এখানে আমরা CRLF দিয়ে দিয়েছি। সো এটা এই CRLF দিয়েও অ্যাসাইন করা যায়, আবার ওই যে ওখানে যে আমরা কিভাবে অ্যাসাইন করলাম উপরে ওইভাবেও অ্যাসাইন করা যায়। এই যে এখানে ওকে, এই যে এখানে দেখেন এখানে নিউ লাইনে অ্যাসাইন করছে এই কোড দিয়ে। সো এই কোড দিয়ে আমরা অ্যাসাইন করতে পারি, আবার চাইলে ওই কোড দিয়েও অ্যাসাইন করতে পারি। Okay, so please study chapter 4 and chapter 5, whatever we studied up to this. Now let's take attendance. Yes, class.